everyone. Thank you for coming to Cloud Next. This session is Cloud Run, Firestore, and Firebase serverless at your service. Now, the English expression to be at your service means to provide help whenever needed. And serverless is here to help your product be successful. I am Sara Ford. I'm a developer relations engineer on the serverless team. And I will be joined by Sylvester Main, who is a Cloud Run customer at Orderly Health. So in this talk, you're going to learn about Cloud Run, which is Google Cloud's easiest and most convenient place to run backend code written in any language. And you will see in the demos how Cloud Run and Firebase work great together. Now, Cloud Run is designed for scale with cost efficiency in mind, which you'll see throughout this talk. And lastly, you'll see a few demos, including Cloud Run Jobs, which is, you could think of Cloud Run Jobs as cron jobs for the cloud. And also, you'll hear Sylvester's customer story. So Firebase is Google's app development platform for web, mobile, and game apps, and it is awesome. With Firebase, you get Firebase hosting, you get managed user authentication, and you get a NoSQL database called Firestore, because you don't know what the schema is going to look like tomorrow, much less in a few hours. So as you grow, you're going to want your own, you want dynamic websites. You're going to want your own APIs. You're going to want AI and ML services. But you don't want to manage all that growing infrastructure. You have things to do. So in this talk, you'll see how Firebase and Cloud Run work great together. Now with serverless, you're not managing physical servers, but you find yourself now managing scaling. When you go to serverless, you'll find that you get to focus on what's core to your business, which is your application development. And with serverless, you get performance monitoring straight out of the box. Here's a different way to look at serverless. So this is a Google Cloud customer's website, the traffic from this customer's website used with permission. And here you can see the consumer traffic. It comes in highs and lows. It's wavy. It comes in bursts, right? So if you want to be able to handle this traffic, you have to open provision the areas in the dark blue to be able to handle that traffic. But what if a famous influencer mentions your site? You don't want that traffic to, those customers to have a bad experience. But you also don't want to over-provision, because that's not fun either. You're having to pay for all of that dark blue area. Scaling can be challenging if you want it to be cost efficient, because you have to make sure capacity closely tracks the demand. Or you could let serverless handle auto-scaling for you. And to use a calculus analogy, because you cannot have a Google talk without a math joke, you think of serverless as paying for the area under the curve. So with Cloud Run, you get to run containers in a fully managed environment. You get an HTTP endpoint, including load balancing out of the box. And Cloud Run implements Knative. So anything that you can put into a container, you can run on Cloud Run. And lastly, there is no cluster management, so no manually managing scaling up and down. Now, although Cloud Run is offering doing all this auto-scaling for you, there's additional fine-tuning you can do as well, in case you even know of like a particular Black Friday, Cyber Monday, high traffic, spiky type of traffic event, or you have certain workloads. And one of those fine-tuning is minimum instances. So let's say that you scaled at 0, so that you have no traffic here, because you're paying for what you're using. You're paying for what you use, and the traffic comes to your Cloud Run service. So Cloud Run is going to spin up an instance. And Cloud Run will keep that instance warm for 15 minutes for free, and then scale back down if there's no traffic within that time frame. But let's say you know there's something around the corner that's going to be a high traffic event. You can set a minimum number of instances warm to handle that traffic. They will not scale down. And I want to be clear on terminology. Cloud Run defines concurrency as the number of requests a single instance can handle at any given time. By default, Cloud Run sets this to 80. You can configure this as needed. All right, let's talk about billing. So with Cloud Run, for billing, you pay for the CPU and memory that you use. You do not pay for the number of requests that you handle, and you do not pay when the instance is kept idle, as we mentioned in that 15 minutes state. So you're paid for so here in the blue, the two blue bars that overlapped, you see that you're paid for the combination of those two requests, for the CPU and memory that you use combined. And also, let's call out in the bottom of the chart the CPU always allocated. So when an instance is idle in that state where it's being kept warm, waiting just to see with up to 15 minutes if more traffic is going to come in before it's scaled down, Cloud Run will reduce the CPU to conserve resources. But if you know I need this ready to go at all times, the CPU, you can also enable that. The CPU always allocated. All right. So for the first demo, you're going to see how you can use minimum instances to keep traffic ready to go. But let's do a slide overview illustration first. All right, so let's talk about what a cold start is. Let's say like you're starting up your service, and there's certain things you want to do in initialization time, like connect to a database, or maybe you have a computational heavy method that you want to cache that result. You don't want to do that every single time a request comes in. You want to cache that and reuse that as when possible. So we're going to refer to that as a quote cold start. But once the instance is warm, any request that goes to that instance up to 15 minutes can reuse that connection or reuse that cache data. But again, if you know of a Black Friday Cyber Monday event around the corner, you can just set minimum instances to be available. And here I've set 2 minimum instances, as you'll see in the demo, that are ready to go. So they're not going to scale down even after 15 minutes, even if there's no traffic. All right, so demos. All right. So the first demo you're going to see is how Cloud Run does automatic auto-scaling, and also you'll see minimum instances. Then you'll see how Cloud Run and Firestore, the NoSQL database, works great together with auto-scaling. And then lastly, you'll see Cloud Run jobs. Let's say like you just have a task or a job you want to run. You don't need to handle like HTTP requests. You just want to run a task or a job. You'll see how you can do that with Cloud Run jobs. Demo 1. And I have these as videos. If you come to the Innovation Hive booth, I'm happy to pull out the laptop and show you these on my laptop as well. And let me just get the first video going. All right. OK, so in this first video, in this first demo, you're going to see how I have a computational heavy method, and it's going to cache it. It's going to take 5 seconds to run. So you're going to see how you can use minimum instances to reduce that latency by reusing it in future requests that come in. I'm using Golang, or using Go language, just to show that if you can put it in a container, you can run it in Cloud Run. And then, I'm caching that in global scope. And also, I'm using main, which is Go's. Anything that's in main is going to be initialized in that cold start. All right. So here, in the hello world request handler, I am calling the computational heavy method. I'm using lazy initialization, which means I only call the method if and when I need to. And notice the emojis. I have a cold, I have warm emojis throughout this demo. You'll see that later. And then lastly, to simulate a heavy computational method, I'm just doing a 5-second sleep. All right, I'm going to use gcloud run deploy command. But notice that there's no Docker file on in the files. This is because I'm going to let Cloud Run use build packs to build the container based on the source code that I have available. And build packs implements the cloud native build pack specification. So I tell Cloud Run deploy command, where's my source? It's in the local current directory indicated by dot. Then I call this demo1 scale from 0, because we're just throwing the service up using the defaults. And then it says, allow unauthenticated invocations. So I'm going to say yes to mimic a public-facing API. And now it's starting to build the container. And I'm going to fast forward a couple of minutes. And now that my container, my service is running, I have a service URL at the bottom. And I'm going to send traffic to it using an open source tool called Hey, just for load generation. I'm going to send 10,000 requests, 100 at a time. So this is Hey, sending 10,000 requests, 100 at a time. But remember, on the Cloud Run side, it can handle up to 80 by default for each instance. Now, it's going to take up at least 5 seconds because of that cold start, because of that initial, the first time we were calling that computational heavy method. And we can see that, too, in the histogram. We actually see 100 requests were sent to cold starts, or were affected by cold starts. It has a time of 6.5 seconds. Every other time I've done this video, I got 5.5 seconds. This time when I recorded, I got 6.5. I think it's because I was recording from home, and my internet service provider was a bit slower. And also, I'm using my laptop here. I was using my laptop to record, so whatever might have been happening also on the laptop side, too. Not a true benchmarking test, but you get the idea. All the other requests indicated by the P95 is 0.0881, whereas P99 is 6.1. OK, so now those instances is warm. I'm going to send it the same amount of traffic, 10,000 requests, 100 at a time, same endpoint. Now watch what happens. Let's take a peek at that, or pay attention to that P99 value. Now we see the slowest request was 0.27, and the P99 time was, oops, let me back up 2 seconds, maybe 2 more seconds. We have P99 was 0.1131 seconds because it got to reuse. No one had a cold start. They all got to use that cache value because the instance was kept warm. But again, and then here, I'm in the Cloud Run service. I refresh. I see the new one I just deployed. And if I go to the logs, I mentioned the emoji. I am a big fan of emoji-driven development. So here we're going to filter by cold start, or by cold. Oh, and nothing like showing your frequently used emojis, in a recording on stage at Next. And here we see 3 instances, so we had 3 cold starts. So we spun up, Cloud Run spun up 3. And just for completeness, I wanted to show those 100 requests that were affected by those cold starts by using a warm emoji. Yeah. Emoji-driven development is fun. All right, but now I mentioned, if you know that there's going to be something around the corner, you can set minimum instances. So here I have it set to 2. And I'm going to send, again, I'm just copying the Cloud Run service URL. And then I'm going to arrow up, delete the first Cloud Run URL. I'm going to replace it with the minimum instances Cloud Run service URL and blast it again, 10,000 requests, 100 at a time. And again, pay attention to the P99 value. Everything's warm because I kept it warm. And here we see that P99 was 0.18. And just going to back up 2 seconds to show one thing that I try to remember to say. This is important. Notice that it said 4 hours ago. So that it was not within that 15-minute. This was kept warm for a while. All right, and then I'll jump back in. All right. I let about 10 minutes go by because I wanted to show you the dashboards. So this is the first service, the scale from 0, where we just deployed a new container. You see that it spun up the 3 cold starts. We saw that with the cold emoji. And then you can see the graph of idle, how it's going, they're spinning down because there was no traffic within that 15-minute time frame. But check out what happens with min instances. We see that 2 requests were kept idle until it got traffic. It got blasted by that Hey traffic. And then you see that it switched, oops, and then it switched to active. So that was demo 1 using min instances. All right, so demo 2, what you're going to see is how you can use Firestore to automatically scale with Cloud Run. So what I did with Firestore is I took my computational heavy method, I ripped all that code out and replaced it with a query to Firestore. And in the bottom corner, it says that it has 100,000 or 100,003 rows to a collection called employees. So again, I'm using pretty much the same code, but in main, I'm initializing the connection to the database because I don't need each request handler doing its own connection. And then here, I am querying all the employees in that 100,000 row collection that are from New Orleans, or New Orleans, or New Orleans. I can do that all day. And yeah, how many other employees are from there? So each request is going to do that query to 100,000 rows. And in the interest of time, I'm going to just skip ahead from the gcloud run deploy. You've seen that now. So I'm still using the defaults. I just want to show the default out-of-the-box behavior. And I'm going to send, again, I just like these numbers, 10,000 requests, 100 at a time. And then I'm going to use that new Cloud Run URL, or Cloud Run service URL. So each request is going to do that query. I hear the next room is getting excited too. And we see that P99 is 0.4288. So the only customization, the only change I made to Firestore was just tweaking the production rules for rewrite tweaking the rules for rewrite to a production database. That's the only, everything else is out of the box. And then the final demo is Cloud Run jobs. So let's say you don't need, let's say that you just have a task or a job that you want to run to completion. Here you see that the last entry is August 7th. And I just want to see how many new employees joined last week. This time, there's no entry handler. Everything is in main, because we're just going to query the database from start to end. Here, I'm just want to say, hey, give me all the employees who joined last week. And this time, instead of doing gcloud run deploy, I'm going to say gcloud run jobs deploy, because this is a job. I give it the source location. I give it a name, demo3. But notice that there was no prompt for unauthenticated invocations, because you're not handling requests. You're just running a job. And now that is finished, I can say gcloud run jobs execute, and then the name of my job. And so it's running now, and it's querying to find out all the employees, and it's actually running it into that weekly report. So here we can see August 14th has 140 new employees, was updated, and I can go to this link in the terminal to go straight to the Cloud Run jobs page for that job. Notice that it says task 0. I could also do batch processing and have multiple tasks. Here I only use a task 0. But one of the things that's also awesome about tasks and Cloud Run jobs is that you can have long-running jobs. You can have jobs that run for 24 hours. So each task can go up to 24 hours. And then each task has its own logs. Just, again, for completeness, the engineer and me, you see that it logged 140 new employees, just like in the database. And then lastly, I'll show you the cron part of cron jobs for the cloud. I can use, you can use a Cloud Scheduler to schedule this, and I'm going to put it every Sunday night at 11:59 p.m. to trigger this Cloud Run job. So that concludes demo 3, Cloud Run jobs, cron jobs for the cloud, and now I'm going to invite Sylvester on stage. So.
Hi, I'm Sylvester, an engineer at Orderly Health, where we have been working to create the most accurate view of provider data possible. Orderly Health has a variety of products available that help you assess your data needs, help you automate your ingestion and outgestion, enhance your data, or we could help you build your own provider directory and manage it. But how do we do this? Serverless. So our history is basically a story of how business used serverless technologies to build, adapt, and scale over time. We use cloud functions to get ideas out quickly. We use Cloud Run to consolidate things when it was convenient. And we use BigQuery to push down our workload so we didn't have to manage all of that Spark infrastructure and things like that you normally do in ETL processes. So here's the story. In the beginning, there was Sean and some data scientists. And they followed the normal route to grab data from here and there. They saved it all over the place on their laptops. And they manually toiled to get the data sets built that served our customers. And it worked, and the customers were happy. But if anyone ever asks, oh, how did you go from input X to output Y at time Z? You had to go spelunking through random data science notebooks and laptops and folders, and it wasn't fun. So we hired some engineers to automate Sean. The first thing we did was we took all the data and we pushed it up to the cloud into Google Cloud Storage and set up some standard rules for, all right, this is how you name your buckets and paths so everyone's on the same page. And then we did the same thing on Cloud SQL. That worked with the data in the cloud, backed up, resilient, and accessible by everybody, and consistent. We were able to now focus on automating the ETL processes that we had going. But we overshot a little bit. We focused on building software instead of pipelines. And what we ended up building was like this complicated, bespoke thing where we were building our own frameworks and stuff like that. And it made it difficult to enhance and to debug and to expand. So we had to take a step back and think like, what are we doing? Are we in the business of making data or reinventing the cloud? Data. So we took that system that we had built. We didn't throw it out. We took all the lessons that we learned and the good processes that we figured out and started to think, how can we simplify this? One of the first things we did was we went from ETL to ELT, so we could get all the data into the system by as simple means as necessary, and we sunk it into our data warehouse, which was BigQuery, which, like I said, was useful because I didn't have to manage my own warehouse or build it myself from scratch. And then with all the data in one place, we could start to ingest it and process it and start to develop our in-house methodology, our algorithms that we use to form that best view of the world, of the provider of data world. And once we had that, and we wanted to serve the data to our customers, we cached it all over in Elasticsearch that allowed us to back our APIs with a simple searchable interface. And then we just spun up an endpoint by a simple means necessary, which Cloud Functions allowed us to do. Over time, we started realizing everything's data, therefore everything's a data pipeline, therefore the same practices for ingestion or outgestion and the methodology, they're all similar. So we were able to automate all the things. And actually, we were able to consolidate some of the practices to go faster. At this point in time, we had a pretty thin method for doing our ELT, our ingestion, our outgestion, all the things you'd want to do when you're dealing with data, which is kind of a big deal here. And we started expanding our offerings. Once those expanded, our endpoints started to expand as well. And at that point, we took a step back and said, well, there's a lot of replication here. Like, we're duplicating logic. So we should start to consolidate this somehow. We thought, well, we could extract commonalities, put it into libraries, but then we'd have to inherit the overhead of managing CI/CD systems, pip repos, the life cycles of those things. Or we could go the efficient route and consolidate it into one service. So we did that. We consolidated it into one service so that all the common code was there. Everything else sat on top of it. And it was pretty easy to do because, Cloud Functions are basically, well, we're using Python. It's essentially like a single Flask endpoint running on top of Cloud Run under the hood anyways. So the consolidation was trivial. Same code, less of it. So yeah, essentially, our story was a history of building, adapting, and scaling, and using serverless technologies allowed us to do that because we didn't have to manage the infrastructure, the scaling, all the things you get with a serverless solution. Cloud Functions allowed us to get our ideas out quickly. Cloud Run let us consolidate or run bigger jobs. BigQuery became our workhorse for our data transformation loads and things like that. So, yeah, that worked out. Since the beginning, Google was with us, helping us out via the Google for Startup Cloud program. Their credits allowed us to focus on building instead of worrying about software costs. We had experts there to answer questions for us. And whenever we had a problem or an idea, we had people to spitball with, and they would give suggestions, which was really helpful. And we also got a few sneak peeks, which was nice. So I'm going to hand this back to Sara. If you want more information about that program, you can scan the QR code. Thank you.
Okay, so what's next? If you're interested in Cloud Run or Cloud Run jobs, we have quick starts. And if you're already in the Firebase ecosystem and you want to try out Cloud Run, Firebase has docs specifically for serverless, for Cloud Functions, and Cloud Run. And there's also some other talks as well at Cloud Next. Okay, again, takeaways. Cloud Run is designed for scale with cost efficiency in mind, and you also get additional fine-tuning. Cloud Run is great, Firestore is great, but you know what's better together? Cloud Run and Firestore, Firebase. And then also Cloud Run Jobs is cron jobs for the cloud, and remember, up to 24 hours processing time. Again, your feedback is appreciated. Please, if you haven't already, download the app. Let us know your feedback, and thank you.